Okay, Alicia. When I went to your particular problem, yeah, it was 21. The one that I pulled up on yours had different numbers than what you sent me on your work. So I just went ahead and worked through with the numbers that were provided to me, which, like I said, were different than what was on your work. So I don't know if it changed them up. Anyway, I saw how you would set up your equations based on the information, the manufacturing time, the finishing time. So your setup looked accurate. Like I said, I could tell that you had different numbers. I only assumed that they were accurate because I couldn't see your identical problem. But you'll set up an equation based on your manufacturing time and the fact that, you could only spend 102 hours or whatever manufacturing them, and then you could only spend 63 hours finishing them. So you have very similar equations set up, and then you also had the x and the y equations. Let me explain where those are coming from. I don't know if you may already understand that, but basically these are equations for the x and the y axis. So they are part of the setup because what we're doing here is we're determining how many skis we need to make of each type to maximize our profit. Well, you're not going to have a negative number of skis being able to be produced. You can produce 0 skis of a certain kind, but you can't produce a negative number. So that's why they're constraining us to that first quadrant, basically, because the x and the y in question here represent different types of skis. Like we're going to be using the x for the downhill in my setup and your setup. I assume, like I said, yours looked very much like this. So downhill and cross country are your variables here. So the x is going to represent how many downhill skis. The y is going to represent the many cross country skis. So this is a manufacturing equation. 3 hours for the downhill, 2 hours for the cross country, and you can only spend 102 hours manufacturing, and then you're finishing, okay? So I really didn't work with these too much other than to establish that is constraining us to the first quadrant, okay? After that, I was really dealing with kind of a 2 equation system of inequalities. And you'll see the way that I approached it, I couldn't really follow the way that you were doing it. So if it's different and you want me to kind of go that way with it, I'm happy to kind of try to make sense of what you were doing or the way they were explaining it. But the way that I approached it basically is I took each of the individual equations here, put them in basically y equals mx plus b, slope-intercept form, so that I could easily kind of sketch a graph. So you'll see me doing that with a 3x plus 2y equation by subtracting 3x, dividing everything by 2. Same thing for this one, subtracted the 1.5x and then divided by 1.5. So ended up looking like what you see me circling there. Now these are quite large equations, right? Like with your calculator, if I had batteries in this one, I'd probably graph them for you on here just so you could have a better idea. But this, you don't have to have that kind of a calculator. So you'll see that over here, I just kind of sketched them. It couldn't really be precise, like I said. Anyway, the first one has a y-intercept of 51, and then it had a negative 3 over 2 slope, so down 3 over 2, down 3 over 2. So this is strictly ballpark, don't really know where they're at. And then the other one had a positive 42 for your y-intercept and then a negative 1 slope. So again, I just know they kind of behave. They both have negative slopes, okay? And so this kind of gives me an idea of what's happening as far as, these two lines go. And also what we do know is that as far as the shading, as we would probably call it with inequalities, 0, 0 makes both of these true. So if I put in the order pair 0, 0, 0 is going to end up being less than what would be a 51, and 0 is going to end up being less than a 42. So if you can imagine shading these like you would a regular system, you're shading on the 0, 0 side of both of them, which causes this shaded area to be your overlapping region, so your solution essentially, okay? So this is a quadrilateral, really, a 4-sided figure that is our solution, okay? Which means that it has some boundary points that we need to discuss, because those boundary points are going to be the ones that we substitute in to see where we're maximizing our profits. Of course, the origin is one of them, because again, we can't be negative for those skis. Up here, you can see it's the y-intercept of that second line, so we quickly know that was a 42. So that was one of my other boundaries. The other easy boundary to figure out is this one down here, because it's the x-intercept of this first line, that one that had the 51 y-intercept, and that's what I said, it's the x-intercept of the first equation. So because I didn't have a fancy graphing calculator, I went and I actually figured out where is the x-intercept of that first equation. So I went to that first equation, put a 0 in for y, and just solve kind of like you would by hand to figure out that the x-intercept is 34. So that's your third boundary point or constraint. And then the fourth one we kind of have to work to get. It's where the two lines meet right here. Okay, so it's a combination of some of the downhill skis and some of the cross-country skis. So it's the solution to the system, basically. Like if these were regular linear equations, not inequalities, where would the equations be meeting? So you'll see me basically doing substitution, really, because you'll see that they're both solved for y already. So I took this first equation and in place of y, put this guy in. So that's what you're going to see happening here is I just kind of treated them like equations, used substitution, put that in for y. And then solve for x. So I added 3/2, which is 1.5, gives me a positive 1/2. Then I subtracted the 42, divided. So you'll see that x ends up equaling 18 for the ordered pair that you see right here. And then I take that 18 back probably in, which equation did I used it in the simpler one. I took the positive 18 for x, put it in here, it ended up being negative 18, so y equals negative 18 plus 40, so the y value would be 24. So you'll see I had to move to the next page to, I double checked my answer, my ordered pair, just to see that it worked in both equations. Like if I put in an 18 and a 24, an 18 for x, a 24 for y, both of these did work out. So like I said, I didn't have a fancy graphing calculator, I just kind of did it by hand, and so that did work out for both equations. So my 4 boundary points, I took the 0, 0 out of my work because you can't, if you put a 0 and a 0, you don't make any skis at all, you're not going to make any money. So I just am testing the other 3 points in your profit equation to see how much money each of them will make us. So it turns out, as long as I didn't make any calculator mistakes throughout this stuff, that making the making none of the cheaper ones, I guess it'd be the downhill ones, but making 42 of the cross-country ones would maximize your profit. So that would be how you'd want to answer that question.